Well, this is the big one, folks. The conversion video from electromagnetic speaker to a permanent magnet speaker. And I hope I can do it right without confusing a lot of people. I understand it, but being able to put this across to you might be a little difficult. I may have to take it in very small chunks. Anyway, let's try to get started, and I hope I can get it all done in one video. I hope. If not, once again, we're just going to have to go to another video, and that's all there is to it. So don't whine and cry. That's the way it is. In this radio that we have right now, the output tube is the 2A5. Now here's, as far as electronic theory and everything goes, I'm pretty much of a bottom feeder. I think a lot of you are the same way. Just give me the basics and continue to march. I don't need to go deep and deep and deep and that sort of thing. We leave that for the smart guys. But this output tube is a 2A5, and I happen to know, just from reading and having done other radios, I know that the output tube likes to feel a certain resistance right here. It likes to feel a certain resistance. That gives that tube the old warm and fuzzy, and if it doesn't have the old warm and fuzzy, it just won't work right. Now that resistance is load resistance, and it's referred to as impedance. Impedance, ooh, big word. It just means resistance to AC. Now, why didn't they just use the term? Well, it's resistance to AC. No, they had to use the word impedance. Okay? Now, the question is, how much impedance does that plate have to feel in the 2A5? Well, I looked it up. When I went to the internet and looked up the 2A5 characteristics, it told me to go check with the 6F6, that they were the same. The 6F6. 2A5 and 6F6 were the same. How interesting. This is getting very interesting for us. Now, let's go down here and find out what the plate resistance or the load resistance is on the 6F6. There it is there, right there. This load resistance. 7,000 ohms. 7,000 ohms is the same for the 2A5 and the 6F6. Well, what's so significant about that? Well, let me tell you. This, ladies and gentlemen, is the speaker and the audio output transformer I removed from the Atwater Kent 856 that belongs to my youngest grandson. You'll remember a couple of videos back I found an original speaker for that Atwater Kent 856, and I restored it and stuck it in there, and I removed the permanent speaker and audio output transformer that I had put in there, when I did the restoration. Well, the output tube and the audio and the output tube in the Atwater Kent 856 is a 6F6. 2A5, 6F6, same. Guess what? I can hook this speaker and this audio output transformer up using these two wires right to our radio and not have to worry about a thing. But it wouldn't be fair to just drop it right there, slap that speaker in, and just, go with it. It would be nice if I passed along a little bit of information to show you why this audio output transformer, which is a 125 CSE, why I bought this from Radio Days. It's a Hammond audio output transformer. I bought it and used it with this speaker, this permanent magnet speaker for that 856. But why did I select that? How did I know that this audio output transformer will provide the necessary load that the 2A5 needs and the 6F6 needs? Well, why did I buy that one? Well, there's a little chart that is provided by Hammond, or it was at that time, and they said, this is for this particular type of transformer, the AD 125XSE. Well, in this case, the letter C goes in there, as in 125 CSE. It would be CSE. And we take a look at it now. It says the secondary impedance. Well, the secondary impedance would be the speaker. Well, we're using an 8 ohm speaker. Well, this is a 4 ohm right there, so we can just get rid of that line right there. We don't need that. Here's another 4 ohm. We don't need that right there. There's a 16 ohm speaker. We don't need that one. And another 4 ohm speaker. We don't need that one. Then, of course, we got a 16 ohm speaker and a 32 ohm speaker. Remember now, the speaker resistance is in this column here, which would be the secondary of the audio output transformer, okay? The primary we're looking for is 7,000 ohms. We want 7,000 ohms there. But if we look down our listing here, we don't even see 7,000 ohms. We only have left, what we got 2,500, 5,000, and 10,000. Well, we don't need the 25,000 or 2,500. That's too small. We're going to have to get rid of that one too. Even though it'll work with a 8 ohm speaker. 2,500 is just too little. We need 7. Well, that just leaves us with a 5 and a 10. Both of them, 8 ohm speakers. Well, which one do you use? Well, I asked that same question of a friend of mine on the Antique Radio Forum when I initially put this speaker and audio output transformer in that radio. And he told me, John, just hook up the wires that sound the best and go with the one that sounds the best. Hook up the first set, the second set. Now, the first set would be the black and yellow wires, secondary lead connections, the black and yellow to the speaker. Now, keep in mind, these are the primaries. These will not change. This is brown and blue. Came with the audio output transformer. That's the primary. But the speaker, he said, if you try the black and yellow, which is will show a 5,000 ohm load on the plate of the tube. Listen to it and then disconnect it and hook up the black and green to the speaker, which would be the secondary wires, and listen to it, and that'll put a 10,000 ohm load on the tube, and whichever one sounds the best, go with that. Well, that made sense to me. I could do stuff like that. Even though I'm a bottom feeder, I can hook up wires, and see which ones sound the best. Well, as it turned out, apparently, I don't even hardly remember this, but I wound up using the black and the green from the secondary to the speaker. These two wires never changed. They stayed the same, remember? Now, I had choices of using these wires. I debated whether to cut them out, the ones I didn't use, but I didn't do that. I just put a little heat shrink on the ends and kind of wound them together. The black and the green is what I wound up going with because it must have sounded better. Well, let's go back to our chart and find out what the black and the green was. Well, the black and the green, 10,000 ohms, okay? There it is right there, 10,000 ohms. So, when I hook this thing into the radio, these two wires, I'm going to leave it just like it is. I don't have to change anything here. I'm just going to take these two wires and hook them into the radio where they're supposed to go, which will be over here. Let me see if I can open this up here a little bit more for you. Those wires will hook over here to the speaker plug, and I'll show you where they go later on. Because this entire mechanism right here, this whole setup right here is missing right now. Everything you see here is missing. And we're going to wind up hooking those two wires to that speaker plug. And once we hook the two wires to the speaker plug, the audio output transformer is in. And the tube will feel 10,000 ohms. Now you say, boy, 10,000 ohms, supposed to be 7,000. We're giving that thing 10,000. Does it make that much difference? Does not make that much difference. You can play around with these things. You can hook up these wires at different, as long as it's 8 ohms, you can hook them up. It won't explode on you. It's not going to, burst into a ball of flames. It does really strange. I did that one time. I just hooked up different wires on a different speaker and audio output transformer. And the volume got real low. I mean, I'd crank up the volume all the way and it just wouldn't go. I just sort of experimented around just to see what would happen. Okay, that's the first half of the story. We now know we've got a speaker, 8 ohms, and we've got an audio output transformer with the correct wires going to it. We know that this is going to work because the load on the 285 is the same as it is in that 856, Atwater Kent 856. which used a 6F6 output tube. I hope this all makes sense. Now, let's go to the second half of this mess. The second half of what we're going to be doing involves this 2000 ohm 10 watt ceramic resistor, which will be soldered in place on this terminal strip. It also involves an electrolytic capacitor. Now this one here is a 10 microfarad. It might be a little too small, rated at 450 volts. Or, here's another one, 47 microfarads, rated at 400 volts, which may be too large. I didn't realize I was out of 22 and 33 microfarad capacitors until I got to this part of the restoration. I swore I had some, but I don't, so I placed some on order. They will be in a few days, but we're not going to have to wait for that. Now, what does this resistor, and either one of these two E-caps or maybe a different size, have to do with the next step? Well, we're going to be mounting this ceramic resistor on there, like I said, soldering it up. We'll be placing it against the chassis for cooling purposes, and we're going to fasten the terminal strip to the chassis also. Then we're going to take one of these two capacitor, whatever size capacitor we decide, we're going to put it on one end of this ceramic capacitor like that to ground. Now, depending on the kind of radio you have, you may need one of these at both ends, and I'll tell you why here in a few minutes. But the last time I did this, I only needed one, and it seems to me it was just a 22 microfarad 450 volt electrolytic. I don't know for sure. I just can't remember what it was. Okay, let's find out what all this is all about. We're going to replace this field coil that measures 2000 ohms DC resistance. We're going to replace that field coil with this 2000 ohm resistor. And it has to be 10 watts because it gets pretty hot. We don't have a field coil, so we have to put something in there to complete the circuit. You just can't ignore it. Whether it's a permanent magnet speaker or whether it's electromagnetic speaker, the field coil, it serves two purposes on an electromagnetic speaker. It makes it enables the magnetism to develop, okay? But it also does one other thing. It filters out any remaining ripple that comes off of the transformer. Now here's what that kind of looks like. This is all in very basic layman's terms, so you all can understand this, hopefully. Here's your DC voltage coming out of the transformer, but there's going to be, even after running it through the two filter caps, there's going to be a little bit of ripple, and that can affect the audio. Actually, it'll affect the operation of the 2A5 tube. So they ran it through this coil, so the coil, uses it has two purposes. They ran it through here, which removed the last of the ripple, because what does an inductor do? It opposes AC voltage. It opposes a change in voltage, which basically goes from, if it's an ideal setup, you would go from this little bit of ripple on top here to a nice straight DC line, okay? DC voltage. It is the last chance saloon for removing the ripple, okay? Now, we can't just ignore it. We got to have something in there to take its place. But the problem is, a resistor does not filter out the ripple like the coil does. All right, we don't need the magnetism anymore. We need the filtering action of that thing. But it doesn't. The resistor doesn't do it. Now it will give us our 2000 ohms that we need, but it won't filter that ripple. So what do we do? We'll get a little hum. We'll get hum in the speaker, out of the speaker. So there's where the filter capacitor comes in. We have to add one more. The filter capacitor will take the place of the inductor's ability to remove the ripple, and the hum will go away. Now, if I don't put a large enough filter cap in there, we'll still get hum. If I put too large of a filter cap in there, it puts too much strain on the power transformer. So I have to kind of, this is kind of one of those touchy-feely situations. After we get it all hooked up, we fire up the radio and we're getting noise out of the speaker. I'll gator wire in. First, I'll gator wire in a 10 microfarad at 450 volts. I don't think that's going to be big enough. And then I'll go to a 22. And if that's not big enough, we'll go to a 33, and that should take care of it. Or I'll put maybe a 22 on one side and a 22 on the other of the resistor. The idea here is to get rid of that last minute ripple. We want that hum to go away. So you can replace a field coil with a resistor as long as you use the correct size, being a 2000 ohm. This is a 2000 ohm. If that were a 3000 ohm, we'd have to have a 3000 ohm resistor here. I hope all of this is making sense. And once we get it in, we're going to run a couple of wires, you know, from each end. We'll have this all hooked up here like so. Gator wired in, of course, initially, and then we'll run a wire from here to here. We'll run it over to the speaker plug, to the small one here and the small one here on the speaker plug, the two small holes. That's the best I can do for explanations, guys. If you have any questions, get back with me. That's going to wrap up this video right here. The next video, we'll drill a hole in the chassis. We'll mount this in. We'll connect the wires. We'll gator up hopefully a 10, and if not, by that time the 22 microfarads will be in. We'll gator wire them up, and we'll get some noise out of the speaker for sure next time. Damn, I was kind of hoping we could wrap it up here. We just can't. It's important that you understand what we're doing. All right, let's go back and do a little recap on that audio output transformer. Now we have the tube, and we have the speaker. This has 8 ohms of impedance. This has 7,000 requirement. Oh my gosh, it's terrible. It's not going to work. It's just not going to work like that. We have to have a go-between that'll match them up. And that's where the audio output transformer comes in, okay? Once we hook up the tube, and we hook it. Now you can't use just any old, an audio output transformer is what you want. And then we hook up the speaker. We have, well, in our case, it's going to be 10,000 actually. So we'll just change that to 10,000. We need 7, but we'll make it 10. So we now have a matchup, a matching transformer, 10,000 to 8, and 10,000 ohms of impedance to 8 ohms of impedance, which will make things work fine. Until next time, this is John. I can't leave without making one more statement. I just somehow feel as though I shortchanged y'all in this impedance business. You know, please understand that there's this is for my newbie friends and the guys that don't, you know, never really got too deeply into this stuff, and I'm one of you. You know, I'm right there with you guys. But there is a difference between DC resistance. Now, what is DC resistance? Well, you take your multimeter, you set it up on resistance, you put a probe here and a probe there, and whatever your reading is, that's DC resistance. There's a difference between DC resistance and impedance. Impedance is the resistance to an alternating current. Okay? It is the resistance to an alternating current. You know, people on the Antique Radio Forum would say, I need an audio output transformer, and it measures 375 ohms on the primary. That is, you know, all right, fine, it does. That's DC resistance. But when it comes to selecting your audio output transformer needed for your radio, that is meaningless information. Meaningless. You need to get one that'll give you the required impedance that you need. The required impedance of your output tube. It is the matching transformer between the output tube and your speaker. So if you picked up what the difference is basically between DC resistance and impedance, then I may have accomplished something here today. I don't know. I hope I did. You know, if I didn't, like I said, ask all the questions you want.